Oh, it's Mr. Graham's glass.
No, they're not Mr. Graham's glass.
They look kinda
He'd be
like
caught dead wearing those. He was what? Yeah, because they were expensive glasses. I'd freak out if mine were lost as well too. That's why I keep mine on my head. They never leave my head. Turns out that that's one of the easier ones. So to solve it, where's the 5 by 5? So if you solve the middle, then it's really a 3 by 3.
Yeah, I know. But how do you solve
Okay, that's
I'm here.
all right. Questions on the homework?
No.
Nope. It was fun, except I'm terrible at geometry. I'm terrible at algebra, so it's probably most of the questions.
All right, you got to tell me what the equation was on 24.
X squared plus 3x minus 2.
So A is 1, B is
3.
and C is
-2.
so negative B plus or minus the square root of B squared minus 4 times A times C. A negative times a negative times a negative is a
24x is not -1. That A
She
is
said-
not -1.
no, it's an equal sign.
Oh.
So a negative times a negative,
Positive.
positive. So AC would be just plain old what? Positive 8. All right, so you got a really ugly number all over 2. Really? They gave you the square root of 17?
Yeah.
Yeah, that's what I
All right, so you just get a decimal approximation.
Yeah,
Or you leave it as a
it's-
square root.
It's approximately 1, -4.
Or you leave it as a square root. You know? So you'd say -3 plus the square root of 17 all over 2, or -3 minus the square root of 17 all over 2. You sure you got that one right? That was really weird.
I got that one. I did not get that one right, because I thought I was doing the math wrong. It was the same way for number 22. as
Was it?
well.
Yeah.
Let's check.
I even did them. I even entered in the program. I even entered in the whole equation on my calculator just to check again, and they came up with the same answer.
What number is this? 20?
22 and 24.
The one that we just did was
That's what it says. It literally says -3 plus or minus the square root of 17 over 2. So that's the other thing, is that when you have something that's written like this, then we get really lazy and we just say that's the answer right there with an x equals.
Really late. So it's 0.5615528 and -3.5715528 3.
Right. All right, I'll collect that at some point. Hey, the test was mediocre at best.
That's how we did.
Yeah. 2 A's and 2 non-A's. A and A and 2 non-A's. All right. It is what it is. Some of you got caught up on 3 and 4. So 3 and 4. 3 is a median. A median goes to the middle.
Wait, whoa. How did you count me wrong on that?
Hold on, we're not there yet. We're on 3 and 4. And 4 is an altitude is what we're looking for. All right, now I know what Jack's complaining about, which is number 6. And so I want a more appropriate answer than just R and T.
Why?
It's not that R and T is necessarily incorrect, right? But you notice, a more appropriate thing, if you read the theorem doesn't say it's equidistant from a point. That particular theorem says if you have an angle bisector, a perpendicular bisector, then it's equidistant from the sides. All right. So I was looking for RS and TS is what I was really looking for. It's not that was wrong. That's why I only took away, I believe, 1 point, Jack.
You took away 2.
What? Then you must have done something else. I took away 2?
It's RS and TS. You took away 7
I
on my.
meant to take away 1. I'll give you 1.
You took away 7 on my first page.
Who else got number 6 wrong? How many points did I take off?
3.
Oh, you were just way off. You have RN and TN, but somebody else put R and T. I believe.
You took off 7, even though I only got 2 wrong on the first page.
Okay, I'm going to show you how this works. 2 plus 2 is
4.
plus 3 is.
That's a 3. That looks like a 0. Sorry. I thought it was a 0.
Why would it put minus 0?
I thought you did it math wrong. That's all.
Okay. All right. And everything else on the paper was good. All right, page 2. 12 was a popular one to miss. Now, the key there was the fact that those two lines are parallel, AC and BE. Therefore, corresponding angles were congruent. So angle CAB and angle EBD would be corresponding. Therefore, they would be congruent. So that would give you an ASA. And some of you invented 11 as being a hypotenuse leg. So, I mean, I think I even wrote it on someone's paper. We're going to find out that's true. Just not yet. We don't know that yet. That one actually is a hypotenuse leg. We just don't know it yet from what we have. We've never proven that a bisector that goes to the median or is a median is also a perpendicular bisector. So we don't get hypotenuse leg off 11, but oh, by the way, it is. I think one person was confused on 13, and that was it. The rest was fine. You guys did fine on that. 14, everybody got the proof on 14, I believe. And 15, yeah, one person, who was it? Was it Allie? You? Allie killed it, and the rest of you were okay. It was not good on 15. And I already told Jack why he got his wrong. And then some of you just put some really wild. So I circled it. I didn't do everything. I kind of gave up after the first couple ones.
Look, substitution was because of the 90s.
I'm not claiming that's the bad part, right? Right. You also don't have to do that because it says it is an altitude. So part of an altitude means that it is 90 degrees. So you didn't have to necessarily do a substitution there. But I mean, I'm not saying it was wrong. What was wrong was, first off, you said you made a bisector, and then you look what you wrote.
I wrote the wrong.
Okay,
angle, yeah.
But even if you did mean ABC, that's fine. The problem is we just can't justify that it goes through the intersection of CS and AT. Turns out it does because of this is an isosceles, but we just haven't proven that yet. Yeah. So the key there was to pull the two triangles apart, and it falls really quickly that they're hypotenuse leg, because of reflexive property and the fact that you're given that CS is congruent to AT. And then it's a 90-degree angle, so it's a right triangle, so it's hypotenuse leg, and you're done. All right. Don't beat yourself up too badly. We're moving on.
Well,
So
66.
everything that we're going to do today is going to be in the Book of Truth. I would recommend that you're still going to put your theorems on a theorem page, all that jazz, but I would recommend you start right now with the next blank sheet of paper in your Book of Truth, and at the top right, parallelogram. And then we're going to put all the stuff we know, maybe not the theorems necessarily, although you can, but if you just have one page on parallelograms, that way whenever you deal with a parallelogram now, you can always just flip back to this. You got a nice, quick, concise, the what, so what about parallelograms.
Wait, are we going to turn them?
I'm going to take yours then. All right, quiz on Tuesday. Wow, that's pretty quick.
Tuesday?
We might not take this quiz. That seems kind of quick, but plus there's only 2 things. We'll see. I'll look it over this weekend. There's your homework. I don't like to not give quizzes because quizzes are, 20% of your grade, and it's, it's a whole category. So if I only have 2 quizzes, it kind of skews it if you do great on one and poorly on another. So I like to have at least 3 quizzes every quarter, and that way you're not really hurt if you get a C on one and A's on the other 2. Kind of averages out fine for you. I will say number 9 in the book, literally the kids started doing their homework because we finished. I think I'm going to use up all the time here, but we finished it a little bit earlier. I said, get started your homework, and they got started, and they're like, I can't do number 9. And I was like, can't be that thing, you little, math neophyte, and I couldn't do it. And it took me literally 20 minutes of racking my brain to try to figure out number 9. Would you?
Challenge accepted.
Challenge accepted, but don't look at it now because you don't know the rules yet. But number 9, if that's the one that trips you up, I would like you to think about it. I just want to use as an example of when you run into problems with geometry is that sometimes it just requires a lot of thought. And I mean, it's not even a complicated one, but I didn't see it. And then when I finally saw it, it's like, I don't know, isn't there a whole website about once you see it, you know, or something like that? They show a picture and there's something hidden inside the picture and you finally see it. And like, oh, look, why didn't I see that? It was one of those. 9 is not complicated. It's just, I couldn't get it for 20 minutes. In fact, I stopped my 3rd period and I was like, kids, sit there quietly for a second. I'm trying to solve something. So I took 10 minutes of their time because I refused to put the problem down to solve it. All right, so we're going to start parallelograms. So in your book of truth, you got one page. It just says parallelograms on the top. So first thing, what's the definition of parallelogram?
A four-sided.
Oh, I'm sorry. That is, before we know it's a parallelogram, that is obviously a...
Rectangle. No, parallelogram.
No, before we even know that, that is a...
Quadrilateral.
So what's a quadrilateral?
A 4-sided shape.
Polygon.
Polygon.
Okay, 4-sided polygon. So if you need to write that down, write it down. Doesn't need to go on the page of parallelogram, but you need to write that down. That's what we're talking about. So by the way, how do we name quadrilaterals?
A, B, C, D. Or left.
We pick a vertex and either go counterclockwise or clockwise, right? Here we go. This is a parallelogram. So what makes a parallelogram?
Then the sides are equal.
Yeah, the sides are equal.
No.
Oh, I've already solved. I've
No.
already solved 9 then.
What makes a
Oh, that's
parallelogram?
your classroom exercise. Never mind.
And we're going to say it just slightly more precise than that. Which 2 sets? And she's right, it is 2 sets, but which 2 sets? So for instance, I could say, well, these 2 sets are parallel, or these 2 sets. Which sets are parallel?
The vertical, the opposite sides.
And that's how we're going to define it. So parallelogram is quadrilateral with both pairs of opposite sides parallel. And notice remember the little red triangle things mean
That's
parallel.
gonna happen with any quadrilateral.
No, not trapezoid.
No, yeah.
Not a weird looking quadrilateral either. But it turns out that most of the quadrilaterals that we know are parallelograms. Not all, but most. Square, rectangle, parallelogram, they're all parallelograms. Rhombus. And remember, we can't use anything until we prove it. So even though you know what squares and rectangles are, we don't know them yet. We'll know them next week.
But what if I already know them?
Yeah, but we haven't proven it. We got to prove stuff in geometry.
But I already proved it like 10 years ago.
No, you never proved it.
You never proved it. You know that they're squares at a kindergarten level, but you haven't proved that they're squares.
All right. So we got parallelogram. The opposite sides are parallel. Now, Jack made the claim of. He made the claim of.
Opposite sides of parallelogram are congruent.
Well, how will you?
Opposite angles of parallelogram.
Well, those are pretty bold claims. The only way we get to use that is if we.
Prove it.
Well, guess what we're going to do?
Prove it.
We're going to prove it. All right, but first, we are going to give some word because the proof used these, or the theorem uses these words. All right, so we're going to talk about, this is for quadrilaterals. This might not, these 2 definitions might change for a different shape. But for a quadrilateral, we talk about consecutive angles. Those are, we're talking about inside angles, interior, and those are angles that are next to each other. So McKinley, if I say angle B, what's the consecutive angle to B?
A,
Or
B.
those are the consecutive angles to angle B. Okay, that's kind of easy to understand. So what is not a consecutive angle to B?
Opposite.
8.
We're going to call it.
Opposite angles.
We're going to call it opposite angles. Okay?
Sir,
And this, yes,
are you screen sharing right now?
I thought it was. Are you seeing the back of my chair?
Yeah,
Sorry.
I got the gist of it.
I could have swore that I pressed share. I guess I didn't.
Okay, thank you.
Thanks for telling me, Ben. I would have stayed there the entire time. And then Madison would have said, Mr. C, you just did a video and all I see is the back of your chair.
A lot of definitions.
We're almost done with definitions.
You take a picture of them.
All right. So opposite. Now remember, I said this is specifically for quadrilaterals. You talk about opposite angles of a hexagon, it's got a different meaning. Opposite angles of a quadrilateral are the two interior angles that are not next to each other. So for instance, B and D are opposite each other. And remember when we did triangles, we did, before we did side angle sine, we defined what two sides and the included or the excluded angle meant. Okay. Or two angles and the included side. And we're going to use those in our thing. So let's see if we can prove what Jack claimed.
I claim two things.
He did claim two things, so we're going to have at least two proofs. We're going to have three proofs. All right, McKinley, what am I trying to prove? I'm trying to prove that something is congruent to something else, so you tell me what's our tried and true technique to ever show that two things are congruent.
By turning them into triangles.
Well, I don't see any triangles.
Well, you can make it into a triangle.
Okay, so what do you want me to do?
Make it into a triangle.
What do you want me to do?
Split F and put a line through F and H.
Okay, I chose to do E and G, but D was right. We could do F and H as well too. The proof will work either way. So I'm going to construct segment EG.
Then
Right.
you have to prove that they're SSS.
Yeah, I got to do one of those things. Do you want to start naming these angles with three letters, or you want to do something else?
Let's do label them 1, 2, 3.
Yeah,
four.
let's-
And then we're just lazy, so we do that, right? So we're going to label 1, 2, 3, 4, and it doesn't matter the order that you label. Okay.
Okay. Well, if it's a parallelogram, well, we know it's a parallelogram.
Yeah, that's. Oh, by the way, that's the symbol for parallelogram.
Okay, so then 3 and 2 are congruent and 1 and 4 are congruent.
Why?
Because of alternate interior angles.
Yes, you buy that?
Yep.
Okay.
And then the sides are
Let me catch up. I spent all this time making the arcs. Usually I leave them off and I do them by hand, but this time, since we're doing online stuff, I got to make sure the arcs are there. Okay.
Then we do reflexive, and then we get SAS.
Yeah.
Reflexive.
ASA. ASA.
And then we get,
ASA.
okay.
I was close.
Oh, is that how the proof ends?
No.
Proof ends
Hold
with
on,
CP,
hold on.
CTC. Right? If you show that they're congruent, then that means that this has to be congruent to that, and that has to be congruent because they're CP, CTC. Okay, cool. So we just proved that opposite sides are congruent. That's theorem something or other. 5-1. 5-1. And it states that if you have a parallelogram, that opposite sides are congruent. And I'm just going to point this out. This was never proven to you by any math teacher.
What if I go
In
after-
well, I was your pre-algebra teacher. I just said, hey, opposite sides are congruent. And you were like, yeah, okay, that sounds about right. But we never proved it. Why? Because we don't want to do a proof to 8th graders or 7th graders.
Well, maybe we should, so we can know it.
And the issue with the should part is that we would have to do the basic proofs as well too, and then it turns into a geometry course. So why not just save it for geometry? 7th and 8th graders are okay if you just say opposite sides are congruent. There are a few, like I will say that I did prove to you why a triangle is 1/2 base times height. I did prove that to you.
Then what are we gonna do when we go back to algebra 2? But then you're just
Everything gets proven in algebra 2 as well.
Oh, so
If you ever do something important and it's some new concept, you'll see it. I mean, you can open up the algebra 2. I don't have a copy of it here. I haven't went home. But you ask any of the algebra 2 students, look at their book, and it'll say proof of this particular theorem. Okay. Just that in all the other classes, there's very few things that get proven to you. Okay, let's do another proof. What was the other thing we wanted to prove?
Opposite angles of an interior.
Okay.
Opposite interior angles of a parallelogram.
So we just have to
We
switch
wouldn't say
everything.
opposite. Okay, we would say, yeah.
We just have to copy from this paper and just change it.
Oh, very nice. So what do you want me to do?
Do almost the exact same thing you did the first time, all the way up until about
Until the end.
about the end. Yeah.
And then you just do CPCTC.
Now I'm going to introduce you to a really lazy math technique. So we just proved that that triangle is congruent to that one. What can I now claim?
Opposite sides of interior.
Yeah.
No. I proved that that triangle is congruent to that triangle. What can I now claim?
You can
Can I
now
both
claim.
those things?
Yes.
No,
No, you can't.
you can.
You
claim
have to do
F8,
another triangle.
But you
for
can
each of
claim
them.
that it's congruent.
So what can I claim now?
F is congruent to H.
right? And then I would have to.
Do another triangle, 2 triangles.
So this happened a long time ago. Mathematicians were lazy. They're like, I'm not doing that. So guess what they write?
The number.
Similarity after constructing F8. Oh, okay.
They just basically say, oh, by the way, if I had done FH instead of EG, I would have come to the other half of that. So this is kind of like a cheap, I'm lazy, not write all the steps. Yeah. Yeah, I sure am.
Yeah, that's
Right.
How can a point be congruent to an angle, Mr. C?
I know, and if you had done that on the test, I would have taken off on you too. Okay, cool. I don't know if I deleted that by accident or that was in my other presentation as well. Okay, cool. So what did we just prove?
Opposite sides of opposite interior angles are congruent of a
We would just say opposite angles are congruent. So, yeah, that's what, 5-2? I'll write that down.
How many still are there?
There we go. You're just now realizing that. When you get animated, the pitch of your voice goes to the roof. All right, so that's 5-2. Oops, sorry.
diagonals of a parallel.
Yeah.
Oh, la la, those are not the droids you're looking for.
Makes sense. Because they're. Wait, so then.
Why don't you write this down first, and then we'll talk about it.
I already did.
All right, so opposite angles are congruent, and opposite sides are congruent for parallelograms. And we are talking about interior angles. So we got two things. We're going to wind up with 4 for parallelograms. All right, we good?
Yep.
All right. Write this down. You're going to prove this in homework. So it turns out that if you draw the diagonals of a parallelogram, they bisect each other. Notice it doesn't say they're congruent. It says they bisect each other.
Wait, but are they congruent?
I don't know. We're going to have to prove that.
But I can prove that easily. We just do the same thing as the last two and add some extra words and boom.
But we certainly are going to get that they bisect each other.
Will I eventually need to prove anything by the end of geometry? And by then I have all the proofs in math I need to do to prove everything.
All right, I should put some tick marks.
Hey.
This one isn't too bad to prove. Clearly, I see some vertical angles going on there. If I could show that either the top triangle is congruent to the bottom one or the left triangle is congruent to the right one, I could get CPCT. I could get a CPCTC, baby. Okay. Let's do another proof. This will be the 4th thing we get.
Given.
All right, we got parallelogram. We're going to try to prove that any 2 consecutive angles on the inside of a parallelogram are supplementary. That means pick a vertex.
E.
We're going to try to prove that E and F are supplementary and E and H are
Well,
supplementary.
that's easy. You just have to do something that I can't think of right
All right, so this one's a little bit harder. Are we trying to show that things are congruent?
now. No.
So we're not going to use our tried and trusty method, right?
But you could use it to help get somewhere.
Maybe. All right. Well, how do you show that something's supplementary?
By turning it into a triangle and figuring out if it's
More
supplementary.
generally, how do you show that something's supplementary?
Oh, you use theorem 5-3 to cut it in half, kind of making that.
More general, how do you show that something's supplementary?
By saying it's supplementary.
Okay, what does that mean?
Oh, add them all up together and say they're equal to 180.
That's what we got to do. So we got to add F and E and show that it equals 180. So I mean, I know how the proof is going to end. The proof is going to end when I say that E plus F, or the measure of F plus the measure of E, is 180. All right, so this one's a more challenging proof to come up with. So I'll just help you out on it. So let's just say that F is congruent to H and E is congruent to G. Why can I say that? Or simply because you're not going to remember that after today. Opposite angles are congruent of a parallelogram. Okay, so we know that right there. Why? Because opposite angles of parallelogram are congruent, and it is theorem 5 2.
2.
Secondly, right, we could say because they're congruent, we could say the measure of that equals the measure of that. So what's the reason?
Because definition.
It's just the definition of congruency. Okay.
That's what
Now, why do I want that? I mean, why do I care about this?
Because it helps.
Because
then
what
you
I'm
can-
trying to do is show that
Yeah.
the measure of angle F plus the measure of angle E equals 180.
Well, then you just have to say they all add up.
So check it out. I got the measure angle F equals. Unfortunately, it doesn't say anything about 180, and it doesn't say anything about angle E.
Well, then turn it into the theorem 5-3. You turn it into an X, you can use the.
We need to get a 180 in there somehow. This one's challenging. This one is challenging.
Make it.
Any ideas?
Make it into a triangle.
Triangles have 180, sure. Yeah. Maybe there's something there. The problem is when you make that diagonal, we're trying to show that consecutive angles, right, turn into 180. As soon as you draw a diagonal, then you just cut. If I'm trying to show this one and this one, I just cut this one. So drawing a diagonal is why you probably don't want to do this. There's one other thing that we can say that we've had a couple chapters ago. Was it last? No, 2 chapters ago. 2 chapters ago.
The interior angles of a. Was it the interior angles of a parallelogram add up to 180? Or just
Yeah,
the interior
probably.
angles of a parallelogram? Yeah, they do add up to 1. No, they add up to
360.
n minus.
What'd you say, McKinley?
360.
Why 360?
Because it's
The sum of the interior angles of the polygon. Add up
Oh, yeah.
n minus 2.
All right, how many sides? 4. 4 minus 2 is 2. 2 times 180, 360. So we could say that. Now we got an equal sign, and we got a number. It's not 180, but maybe there's something we can do. That is, well, I just said that some of the interior angles are quadrilateral, 360.
Okay.
I would like this to say E plus F equals 180.
Well,
And then
you
you
can
can-
do that because you split it. You can divide that number by 2 and then put it on both.
But then I would
sides.
have all these divided by 2.
No, just 360. divided
You
by 2.
technically can't do that like that, though, 'cause you could end up with E.
But
No, E. Oh, I see what you're saying. Yes, I agree. Do you say we're not proving that opposite sides are supplementary?
but they could be.
Well,
No,
like
they-
just
Oh,
looking at
we
it,
can make them so they're clearly not. I mean, if
They're
you
only-
squeeze that sucker down to like this, you get 10 degrees plus 10
But
degrees.
and plus, they're only supplementary if it's a.
You can also expand it
Not
like
right,
this,
yeah.
so it would be way bigger, all right? Well, no, that's not true. It'd be bigger than 180, but not 360.
So F and H are bigger than.
Hint. Why in the world did I write this statement?
oh,
Because you can do substitution.
What substitution could I do? And let's just concentrate on one of these at a time, F and E.
you can change angle, the measurement of angle.
So this says that G is equal to E, so I could change this G to and I could change H to and then I would only have F's and E's.
Oh, then you can divide it by 2 because
All right,
then
all right,
they're-
hold on. Let everyone else enjoy the moment, all right? Now I could do what over here?
2 times measure angle plus 2 times
I could just group like
angle.
terms, right? So I could write
2 times the measure of angle E plus angle F.
keep that thought.
2 times. Measure.
There's 2 E's and 2 F's.
Right. I mean, you could just do 2 parentheses times. measure
Oh, I
angle
like
E
that. We
plus
could do
angle
that.
F, and then it would be much easier to divide by 2.
Maybe. I mean, I would argue it's the same way.
So then you get that measure of angle F.
And by the way, this is just combining like terms. And then let's divide everything by 2.
Then you get measure of angle E plus measure of angle F equals 1.
And isn't that the definition of supplementary?
Yeah.
So I just proved that F plus E, and guess how we're going to end this proof?
Repeat for the next
Similarities.
Similarly, the hardest word I can never say, similarly, right, you can do the same thing for the other.
Or you could just say, I'm too lazy to do the rest.
Yes, no, remember, that's just definition of supplementary. Okay, so we just proved it kind of got lost there. What did we prove?
That
Numbers equal each other. Yeah.
You take a parallelogram
Oh, yeah.
and you get
They all, it all equals.
consecutive angles that they are supplementary. All right, write that down. That's something. They actually don't write this down as a theorem, but we're going to write it down. So on your parallelogram page, we now have 4 things. We got that opposite sides are congruent.
I sold 9.
We got opposite angles are congruent. We got the diagonals bisect each other. And then lastly, consecutive angles are supplementary. This one doesn't get a theorem. And the reason why I throw this in there is because it's used in homework. And they don't even mention it. It's like the first thing you do. One of the first things you do. And the reason why they don't mention it is because they want you to remember a parallelogram obviously has what? As the name would imply. A parallelogram has
4 sides.
Parallel for 2 parallel.
Yeah.
and if I just draw the top and the bottom, and I draw one of these, what's the construction that I have?
You just have 2.
I've got that thing with a transversal. So all that stuff that we have with it, alternate interior, alternate exterior,
just proved it by
we
that.
could have just said same side interior angles. We could have done that as well. couldn't we?
I thought about that. I just
Yeah,
didn't know how to say
we
it.
absolutely could have done that.
Wait, Mr. C, I just sold 9.
Well, I'll check it here in a second. All right. So let's look at what these questions will look like. Why is G supplementary to M? We just proved it, right? They're consecutive angles. It's a parallelogram.
There's got to be, can I just call it theorem 5-4?
No, because that's going to be a different one. If M is a right angle, what can you say?
Then G is a right angle, R is a right angle, A is a right angle.
Because of what we just proved, right there. Okay. All right, these are the more, and it's hard to see, I know it didn't come out that well. These are the harder ones. It's not impossible, the harder ones. So let's see if we can get these knocked out. All right, Anna, you get the first one. You can pick one, X, Y, or Z, and tell me what it is and why. You may have to use some calculations.
65 degrees
There's a couple of ways you could say why, but why?
because of the side.
Well, same side interior would be this one and this one. And then that would be supplementary. No. What do you got? Okay, this is hard, but you got to always remember this since we have parallelogram. We got 2 parallel sides, that one and that one, cut by the transversal. So any corresponding side will be any corresponding angle will be congruent. So that's why you can say immediately X is 65. All right, McKinley,
All you have to do is
pick
65
one.
7.
Pick one.
Well, you could do A and D.
We want Z or Y.
D.
How big is Z?
65 plus X equals 180. I mean, plus Z equals 180.
Say that one more time.
65 plus Z equals 180.
And then therefore you could solve that, right?
Right? Solve that
We
with
can do that in your head real quick.
No, I can't.
What is it? 115?
And then C must be. No, it wouldn't be.
You just said Z. So Y is,
It was 60.
well, what's the easiest way to get that?
Because of
Ooh, you saw that. I saw something else.
Math.
wait, just opposite interior.
Opposite angles are congruent. What they said was alternate interior. That's fine as well, too.
Oh, yeah, I see that.
Okay.
But typically, when they just give a parallelogram, that's all you see. So, but remember, you could always do this little trick right here. And then those are alternate interior angles. All right.
So you could also have proof that opposite angles are congruent.
We could have proven that the exterior angle of a parallelogram is equal to the,
that angle, and then therefore
I don't know.
that is congruent to that because of alternate.
then what
interior.
now?
Then therefore the exterior angle is congruent.
Oh,
to
so
the-
you're saying we could have proved that that was congruent to that by something like this?
Yeah.
Yeah, maybe we could have. Maybe we could have. All right. This one's a bit more challenging. So this goes X, Y, Z.
Well, you could.
Ben, what do you think X is?
X,
Middle one, number 4.
kind of hard to see, but I'm
It is.
pretty sure X is just 95
Where are you getting that from?
because
That would equal 180, Ben. Then you can't have B, D, C.
wait, no, my bad. 70.
So Ben, pick X, Y, or Z and tell me what it is.
It's hard to see on my screen. Like,
The bottom left
wait,
is
I
Z.
was looking at a different. Oh my
You were on 4.
god. On number 4. Gosh, I guess I'll do X.
X is the hardest one. Z is the easiest.
Why is X the hardest? X is easy. X is
Trying to
easy.
trick you.
It's 56.
Z is.
Thank you for ruining it there, McKinley.
I'm sorry.
Y is the hardest one.
No.
Why just 56?
Yeah, yeah, maybe.
It would still be 56 because it's the number.
Yeah,
thing.
I agree. Why it's the hardest one?
It would,
But-
no, it would be 80.
All right, Ben, how big is X?
X is 56.
Bottom line, 56, because its opposite angles are congruent.
Ugh,
All right.
Yes.
From there, I guess Z would be the next easiest one.
85.
85.
And then Y is Y, you're claiming it's hard.
56.
Because you have to do calculations.
Okay.
30.
So 56
So
plus
39.
85.
Now,
Is that right? 39? You said this is 85. Oh, yeah, it would be. That's right. Okay. Last one. This goes X, Y, Z.
110 for Y.
X is 110.
All right, that's the easy one. So is Z.
Z is 70.
And Y is.
70 plus 110 and plus X equals.
Whoa, wait. What?
What?
You said this is 110.
Yeah.
You said Z is 70.
Yeah.
Ooh, we got problems now, don't we?
Wait a second.
Oh, it's 110
Why?
because
Oh, yeah.
the same size fingers or the fingers is proved.
Consecutive angles are.
supplement.
So which ones are consecutive?
Oh,
No. 70. No, it is. It's 70.
Teachers, dismissal is about to begin.
All right,
At
so
this time, please
No, it's
dismiss
not
all
70.
5th through 10th grade walkers.
Wait,
I
yes,
would-
it is 70.
I would concentrate on this part right
It
here.
is 70.
Again, please only release 5th through 10th grade walkers.
If this is 110. How big is that?
Oh, yeah. And
oh,
yeah.
See it? So it's 70. Therefore,
That's 70.
that's not 70.
No, I was talking about the vertical angles.
Oh,
So why is
so that's 77, 140. That's 40, and then alternate interior, so that's 40.
You
So
have also done it because of vertical angles.
say again.
Vertical angles.
and then
And then
What?
vertical angles, and then because.
Oh, right. I got you. All right. You gotta show me why you think 9 is 9.
Because A squared A squared is B, so then this is an isosceles triangle, so this is 56. When you got the vertical angles, X is 56. And then Y, and then if this is 56 and this is an isosceles triangle, this is also 56.
You could also write it because it literally says 8. For some reason, I didn't see that. And we were staring at the angles, and we were trying to do all sorts of things with the angles. We weren't paying any attention to the sides, and then I finally said, "Oh wait, it's isosceles." Number 9. The hint is it's isosceles one or maybe more of the triangles.
Well, you also have to figure out that the other one is isosceles because of the bisector and because of the
I don't know if you get to see if it's a
because
bisector
you have
or
to
not.
figure out A and B too. And
Yeah.
it is a bisector because of theorem 3.1.
Well, it's absolutely bisector. I'm saying because A is
A is 8 and then 8 is B. Because
Then
of
eight is-
B is 8.
B is 8 because it's opposite side.
Yeah, and then so this
So
is
that's an isosceles,
so then
right?
this is
So that's
56, so
56.
it's sex.
Correct. Good job. You got it before I got it.
Well, I was also kind of staring at it most of class. So.
Well, I'm okay. Then you got it as long as it took me, because I literally stared at it, and I was like, it's only number 9. Come on, it can't be that hard.
Yeah.
If it was 22 or 23, those are. There's been a couple proofs in the books I haven't been able to figure out, and I got the teacher edition, and it doesn't tell you. So
Oh, really?
not for the proofs. I mean, it told me the answer for this one, and by the way, with 9, so the kids saw in the back of the book as well too. So
Yeah.
But we were like, okay, we know it's 56. Why is it 56? And
Yeah.
Yep.
Yeah, that's it.
Annoying. Have a good weekend. All right, Ben. Doing any fun this weekend?
Please
Uh,
and notice for Caroline. Remember,
Well, my mom is in Kansas helping her friend with a baby, so she'll be home tomorrow.
Well, that's good. Get your mom back.
Yay.
Yay. So you're doing the cooking and the cleaning this week?
No, I don't want to.
161
Do you cook at all?
346
Sometimes.
Yeah, it's a good skill to
Good at
learn.
it.
Yeah, it's a good skill to have. All right, Ben, I'll catch you next week.
Goodbye.